Thank you very much. I'd like to welcome everybody. My name is Wendy Olsen, and I'm going to talk about what is QCA. QCA stands for Qualitative Comparative Analysis. So it's a set of systematic ways of studying causality in a simple data table of binary variables. You can use ordinal variables, and then you would call it fuzzy set QCA. So that's where there's different kinds of it. There's the crisp set QCA and the fuzzy set QCA, and there are a couple of others. So it's mainly used in comparative research or with qualitative data or as a part of case study research methods. So it's quite a wide range of uses. For example, it's been used in forestry research and sustainability, in studies of fair labor in the footwear trade, and in many, many other areas, including health, education, political science, and social policy. QCA helps you to discern necessary causality as well as sufficient causality for small samples. So it's really meant for samples of about size from 8 to about 200. QCA offers formal methods for analyzing qualitative data about the characteristics and the contextual backgrounds of these cases. So I'll be explaining all about QCA. My aims are about 5 tasks, really. First, setting out the basic assumptions of QCA, and then to present the logic of a QCA from an established seminal paper. The one I'll cite is in sociology. It's by Cress and Snow. The third task is really to say how a model is estimated in QCA. It uses Boolean algebra. And the fourth task is to illustrate the main software packages used. They're very easy to use, I'm pleased to say, even though the Boolean algebra step is a little bit hard. And there are slides here giving additional examples and references. And I have brought with me a book by Charles Ragin about QCA. So perhaps that book can circulate so that you can see what the material looks like. And the references are in the slides at the back. So I'll start with these assumptions, the basic assumptions of QCA. I'm particularly interested in these because of the contrast with statistical methods. So the first one I'll mention I call regional ontologies. But that means that for a particular space and time, what exists actually might be different from things that exist in a different space, a different part of the world, for example. So the way Cress and Snow mention this is very important. They say one of the primary difficulties in assessing the factors theorized to affect outcomes is operationalizing them in a fashion that is consistent with the literature and yet relevant to local contexts. So what they're saying is their work, which in this case was across different cities in America, had different local contexts which differed enough that it was actually sometimes hard to make a concept fit a particular city because the conditions were different there. So a regional ontology is a theory of what exists in different places, really quite differently, and not a universalistic ontology. So if you put it differently, we don't see causes simply as mechanisms that cause outcomes. We have the context and the mechanism together lead to the appearance of an outcome. But the mechanism is only working in that context, and it might not work if it was outside of that context. In fact, the ontological point is that the mechanism itself, like a social policy of a city, it might actually be different in a different context because of its interactions with other aspects of the context. And this has been described by Pawson and Tilley and arises from research in philosophy by Roy Boschker and Andrew Sayer. So it really has a very strong foundation, in my view. The second point of basic assumptions underlying QCA is the conjunctural logic, and you may link this up with complexity theory. QCA is conjunctural in its logic, examining the various ways in which specified factors interact and combine with one another to yield particular outcomes. So in a way, I'm repeating an earlier point. But here we notice that the world's conjunctures are changing at different speeds. We don't expect some of them to change very fast. Perhaps social class, but some of them we expect to change very fast, so like the regulation of fair labor in trade. So our claims are definite with respect to the past and the present, but they're conjectural and contingent with regard to the future. And in these ways, the QCA analyst is using a typical qualitative method. It's fundamentally qualitative because it assumes fluidity in the social world. So I'll move on. The third assumption is avoiding overstating the findings. So there is modeling going on here, but we wouldn't universalize or generalize from the modeling. We would avoid using the QCA as a black box approach. And an example of that relates to omitting contradictory configurations. I'm going to come back to that in a few minutes in some detail. So if we were trying to find out what was the case within the sample, we wouldn't generalize very much to what is happening outside of the sample when we use QCA. The fourth assumption is really about how we organize the data for QCA. In a way, it's a very simple truth table that results from some data preparation. If it's a crisp set QCA, then this table is all zeros and ones. One column can be used to count the cases, which are of the same overall configuration. And I'll show you a table near the end. And in one column it says 4, 7, 28. That's the number of cases of each type. So that makes the table more concise. One column is set aside as the outcome, and that would also contain just zeros and ones. You can use NVIVO software from QSR International to approach the development of this casebook. So you start with qualitative data or policies or documents or focus groups, and then there's a single option in NVIVO to create one casebook, and the casebook can then be exported. So it can have 30 cases, or it could have different levels of cases. It could have cases embedded in countries. Those things all work very well in NVIVO. There's no other software, among the standard repertoire. Word can't do it. Excel can't do it. SPSS can't do it. If we compare with NVIVO, there are some very good alternatives like MaxQDA and Atlas TI, but NVIVO is the best. So I now want to turn to part 2, and that's the example of Cress and Snow. I'll just tell you a little bit about their research first. It's an ethnographic piece of research, and it was published in the American Journal of Sociology. The topic is how do different groups mobilize resources to help homeless people. But the research included homeless people as participants and voices in the research. It also referred to social movement organizations, which are abbreviated SMOs. And I've brought a couple of key pages from this paper if you want to take one away with you. The key tables are, I just have 2 or 3 copies of them. The very quick summary tables, 1 page, as we were recommended to do by Miles and Huberman in their famous book about qualitative method. So the paper by Cress and Snow uses QCA very creatively. The first thing it does is it notices that there isn't just one outcome, sort of getting more for homeless people. There are 4. We can call them R1, R2, R3, R4. But they refer to rights for homeless people, resources for homeless people, relief for homeless people, and representation. So you can see the paper cutting across sociology, politics, and social policy, and fearlessly taking up what is really there, and not just what is the interest of my discipline. These outcomes are qualitatively compiled based on a series of ethnographic interactions with homelessness activists, with homeless people, with politicians, and officials. They started off with 17 U.S. cities, but they just chose 8 for this particular paper. And the QCA analysis then has a total of 15 organizations because some cities had 2 organizations. They're all listed here, one in Boston and so on. They're actually named in the paper. But apart from that, they used pseudonyms to keep all the individual people safe in the reporting of the research. The crisp set QCA data table then has 4 outcome columns. It has about 8 causal factors, so there's 12 columns altogether. And there are 15 cases, 15 rows. So as I say, it's a very concise summary of the data. So I'll give a quote to illustrate how cautious they are. Most of us would say this was an inductive paper. They say the primary concern is not with generalizing to the universe of homelessness SMOs, but with using our case findings to refine and extend understanding of the determinants of the outcomes of these movements. Given the similarities and differences among our cases in terms of the causal factors, they are well suited for assessing the influence of factors that are thought to affect outcome attainment. Now, this isn't just jargon. This is very carefully framed, where outcome attainment, you could be any outcome, whatever your research has as its main factor of interest, whether it's the success of a treatment or the outcome of a court case or a change in the economy. But they're being very careful with their data, and they're not claiming to make generalizations outside of the sample. So it's not inferential, and it's not deductive in this particular case. So QCA offers originality. It can be based on existing well-known theories or models, but then you can embed the theory and its components into a fresh comparative project on a small scale. You can then add new columns of summary data to that project. So there might be new policies which you need to reflect in an amended data set, and make it original. So it's systematic, and you systematize the data, perhaps by introducing new concepts into the revised data table. I call this retroduction, because I think we go and we meet the society, and we meet up with the facts that we're able to collect as data, and then we try and work out, why do I have this pattern coming at me? Why is this pattern happening? Why does the data appear to be like this? And in qualitative research, we then revisit our scene. We go back into the site and collect more evidence and learn more, and then come out of it. So it's not just inductive, in my opinion. It's not just hypothesis testing. You can do a little bit of that, but it's basically retroductive. That means asking why, going backwards in the chain of causation. So for comparative research, it's extremely useful, because you might only have 5 cases, or if you have the OECD, there might be 10 or 23 cases. So you can't really use inferential statistical methods. QCA also allows for the history of the whole set of cases, so the whole of global capitalist history, or the whole of the court and how the court system works. We call this the macro history, encompassing all cases. It's a substantivist approach. When N is not a random sample, but is the whole population, such as all the countries of the OECD, we really shouldn't be paying attention to significance levels. But there's a lot of papers which do, a lot of regression results on the cases of countries with N equal to 31 or even 17, which I find astonishing. Because you can't generalize from 17 countries to the whole population of 196. It's false. It's not the same population at all. When the sample is arbitrarily chosen, and I'll give an example here from a medical context, but I don't know of any QCA research here yet. You could have a sample of all the people who've died and who have given permission for postmortem brain scans and who had a particular disease. So they'd been diagnosed with, say, dementia. Well, that's not a random sample. That's an arbitrary sample of who was left once these criteria have been met. So again, we should be careful about using inferential methods because there's sampling bias, but we can use QCA to look within the sample at the contrasts. So that sort of gives you the context. And now on this slide, I've made a summary of one of the findings from Cress and Snow. And Cress and Snow have gone through classifying the outcomes, which is on the vertical axis here. Having rights is the one that's shown here. And it's 0, 1, that's no or yes. They didn't develop or get rights for homeless people, or they did. And on the other axis are a vector of 2 factors which are causal on getting rights. The 2 factors shown here are making a detailed prognosis of why people are homeless, which differs from different parts of USA, and the viability of the SMO. A vector is just a combination of 2 factors, and in Boolean algebra, it's x1 and x2. So if both are true, then we move to the right, where x is 1, and the top right corner is 1, 1, where they both have the vector, and they also have the rights. They have achieved rights for homeless people. 7 cities had achieved rights under these conditions, and none had achieved rights for homeless people without that joint condition being the case. So we're looking for this sort of pattern, and my diagram shows none at the left, several at the top right, few at the bottom left, and several at the bottom right. That's a typical pattern for necessary causality. The patterns are different for sufficient causality. They're actually reversed over the diagonal. So necessary and sufficient causality are mutually exclusive in QCA. So according to Snow and Cress, when they come to their overall findings, they noticed that there was no single pathway for a single outcome. There was no general or universal causal pathway in these American cities for the whole set of positive outcomes. You know, even when you put all these 4 things together, rights and representation, which are all good for homeless people, there was no general model that they could achieve or wanted to achieve. So you have to see the paper to get the detailed findings. Hence, I brought a copy. And they did a detailed study of each pathway, interpreting the results in terms of their ethnographic findings. They did shadowing and buddying, and they observed public meetings. And the reasons why things worked were different in different cases. So almost half the paper is ethnographic. So I have a slide here showing the research design that would be typical in QCA. You can refer to the slide later. It just shows the data collection stage, and then the QCA is the data analysis stage, and finally an interpretive stage. But for QCA, we usually go backwards as well as forwards through the research design stages. We can go right back to the sampling and get another case in order to find out, or if you like, test whether it's really the key absence of something that leads to the presence of the outcome. So I want to explain why I would go backwards like that, why I would iterate in my research design. And I'll do that by looking at the Boolean algebra for a few minutes. But the Boolean algebra is a big topic. If you look it up on the net, you'll find huge detail that arises from the disciplines of philosophy, logic, and artificial intelligence, as well as mathematics. So I'll just give some simple examples and illustrations. Suppose we use the small letter b to represent not b, the absence of that condition b. And a capital letter means the presence of something, and y is our outcome. Then if a not b, y occurs, and a b, y occurs, then b seems to be superfluous to the outcome y for that little group of cases. And suppose we then start looking at a, c, and we find a, c, y, and a not c implies not y. Can you see how my notation works? Then it begins to look as if we could drop B, but we need to pay attention to C. We begin to suspect that AC as a combination is either necessary or sufficient for Y. So the Boolean logic starts with that, which is basically and, an or, a not, and then it moves onward. So we can use Venn diagrams to illustrate necessity and sufficiency. Some people like Venn diagrams, and some people don't. So follow with me if you like, but there are other ways of representing this. So if, for example, I'll show you one here for sufficiency. I don't know if you can see this, but the set y is larger than the set x here. So all x's are embedded in y. And that's an illustration of x being sufficient for y. Because if we have this information ex post, then it seems if we know x, then we know that y occurred. And if we know not x, we don't know what happened, because the not x area includes some of the y area and some of the not y area. So that's the use of Venn diagrams to illustrate sufficiency, and the illustration is opposite for the analysis of necessity. So now I have a large x set, and y is embedded in that, and that would suggest that x is necessary for y, because y can't occur unless there's x. The not x space is outside in the boundary of the picture. So this is how Venn diagrams are used by Ragin. And these come from the book that's circulating, which is from Redesigning Social Inquiry, Fuzzy Sets and Beyond. But I have to say that Ragin's been proposing this since about 1994, and even his book in 1991 was proposing this. So it's not really that new, but it's becoming extremely popular. There's hundreds and hundreds of articles using these methods. I'll just tell you something briefly about the fuzzy set variant before we come to further aspects of the Boolean logic. So I mentioned that you could have fuzzy sets, and that would be where, if I go to my slide of Venn diagrams, the boundary between x and y, or x and not x, is more fuzzy, and you can have different degrees of membership in x. That means it's not probabilities, but it's more of a qualitative statement that you're fully like X, or fully in X, or fully have the character of X, like a generous welfare state. And then a less generous welfare state would have low membership in X, and if you had no welfare state, you would have not X, or zero. So this can be represented in quantitative terms. So if I show you an illustration, can you see there's a general triangular pattern in this slide? This is a standard scattergram with the XY axes, and the triangle is appearing in the necessary quadrant of the diagram. So this comes from some other research using countries. Countries are plotted on the graph, and it suggests that X is necessary for Y, but not sufficient for Y. Because I work in labor market context, it's very interesting to know that what happens with women is necessary to achieving a high labor force participation overall. I suppose it's not surprising, but it's useful, and it could be useful in demography. So returning to what is a fuzzy set variant then, we can ask whether X appears to be necessary for Y, even for cardinally measured, quantitative, scaled, or ordinal variables. And fuzzy set QCA really refers to ordinal memberships in sets. The Boolean reduction starts with the raw truth table. So this, I'll go back to crisp sets to keep it simple. This is the set of all zeros and ones, which has particular configurations illustrated by the data. So there's many permutations, but there's only limited diversity, and some potentially imaginable configurations aren't shown in the data table, or we show them but with zero cases. And limited diversity would suggest that we could then simplify this data table into some sort of a short statement. And I'm going to illustrate that for you in a moment with regard to schools in Britain. So each school would be a case, and the performance of the school would be the outcome that we're most interested in. High school students have exams, and we average all the exam results. You can do data reduction to get to the simple data table, and this is something we've been doing. But the Boolean reduction has to be done by software because there are so many permutations. After about 2 causal factors, I can't really go through and imagine all the different combinations and how I test them for their impact on the outcome. So we used De Morgan's law. There are some other rules of Boolean algebra, and the history of the development of these rules is really interesting. For example, Quine, who's the famous philosopher, was involved in the development of the Quine-McCluskey algorithm, and that's one that helps you to simplify the permutations to get these prime implicants. So it is interesting, and it's very well-established philosophy or mathematics. So in the northeast of the UK, we had the Ofsted reports, the inspection reports for 192 schools, and we looked at school performance. And school performance was high if, and here it's the if of sufficient causality, if they weren't in a socially deprived area and it was a Catholic school, or if 2 other conditions applied. Now, I'll tell you what the other conditions are, but isn't it interesting that it wasn't sufficient for them to be not in a socially deprived area? If they were in a not in a socially deprived area, but not a Catholic school, then they didn't have such a high school performance. The other possible solution or modeling result was having a lot of statemented students with special needs and having selective admissions. So both of those can lead to higher results, but not independently. And I think that means there's something about the school administration that's led to them statementing a lot of students or welcoming disabled students. They then get resources if they have these students. They use the resources to improve teaching or do streaming. We're not sure why, but it only had its effect on performance in the context of selective admissions. So that simplified statement is called a parsimonious solution. And that was found by a computer after looking at about 6 different factors. So in short, not A and B or C and D has caused Y for these schools, and that's sufficient causality. We do a separate analysis of necessary causality. So that summarized the sort of black box part of QCA, but there is a very important final step of interpretation. And here we might interpret the general outcome, as I've just done, and also interpret exceptions. So for example, we looked at the exceptions that had low performance in the northeast of England, and looking at some of those groups. We looked for a school inside a low-performing group which had high performance. This is a contradictory group. And we found peer mentoring schemes were in place in at least one school in that kind of a group. And it turns out, since then, we've discovered that peer mentoring is a new fashion in British schools that's been used in other countries and can help learning a lot. But we noticed it in David Byrne, who was really leading on this, he noticed it in the Ofsted report for one school and thought, that must be something important that's helped with students' learning. And you can read about that in a new collection edited by Byrne and Ragin in the Sage, and the references at the end of the slides. So I'd like to turn now to the notes on the software that you use for QCA. As you can see, I've given a kind of superficial review of how some of the results are arrived at. But if you look at it in practical terms, it's much easier to absorb. You can put your data in Excel. Excel can hold qualitative data, has multiple worksheets, and then you can make a front worksheet to contain the truth table as tabular data. But you're basically doing something mentally that synergistically summarizes what's happening for a case. What are its characteristics? What was its outcome? What was an important contextual factor? Dropping all the unimportant material. So it's a summary. NVIVO can also be used to do the same thing. So you might have qualitative textual data, and you code and summarize it, and then create the casebook, and then export the casebook. So I have to mention, here's where NVIVO is superior to other software. It's pretty easy to export the NVIVO data to Excel or to SPSS, or you can import SPSS data into NVIVO to put your demographics in there before you do further qualitative work. So these are tricks which are quite handy. But NVIVO is produced by a firm unrelated to SPSS, and it's, one has to pay additionally separately for NVIVO. This university has adopted it, and the UK has adopted it as a CHEST-approved software, so Pew Systems will sell it to you on an academic discount because of that. So those are 2 software systems just for managing data. And then we come to FSQCA software. That's freeware. That means it's made freely and available to the public on a website based in Arizona, and that can be used for the Boolean reduction. You can't do the Boolean reduction inside NVIVO or Excel or SPSS. You can do it inside Stata, but many of you would find that quite hard to use, and I'm not persuaded that it's better than the FSQCA itself. FSQCA software includes both crisp and fuzzy QCA. Another software package is Tosmana, and Tosmana is useful for a couple of extra things. One is multi-valued outcomes, which we were quite close to with R1, R2, R3, R4. That's the kind of multi-valued outcome. And it's also useful for illustrations. So you can have a sort of a squared-off Venn diagram coming out of Tosmana, which we can't get any other way. I mean, I don't know how to get a computer to make a Venn diagram. I have to make it myself in a graphics package. But Tosmana can do this for you. So I've got a slide that illustrates that. The topic of the slide is the main content of the Ragin book. One of the main examples there from 2009 is the survival of democracy in the interwar years. So from about 1920 to about 1939, did the country have a surviving democratic government, or did it shift to a system of either authoritarian or non-democratic government? So, to me, I'm not a political scientist, and it seems awfully crude. It seems to absorb different time periods and different party systems and non-party systems all into a simple yes-no set variable: survival, breakdown of democracy. So here's my Venn diagram. And this illustrates different instances, and there were only, I think, 17 in here. One can locate the UK in the same group with Germany. So it turns out that's a contradiction. UK didn't have the breakdown of democracy. It had the survival of democracy, but Germany had the breakdown of democracy during this period, which led to the conflicts of World War II. So it's concerning that it's in a contradiction. And this is only an intermediate table. If we go back and we revisit wealth and income, we can separate the UK and Germany and find some way of getting rid of the contradiction. So that's, in that sense, QCA is exploratory. And this example is very well posed, I think, to illustrate how you can move from simplicity to a slightly more complex argument. There is a limit beyond which additional complexity is just confusing. But this argument is moving from an established one by Lipset, very well established in the political science literature, to Reagan's own take on the survival of democracy. And then since then, it's been looked at further by historians. So in the diagram, you have dark and light areas. The darkest one shows the survival of democracy cases. These are Ireland and the Czech Republic, what we now call the Czech Republic. Then it was Czechoslovakia. And the white is the remainders. That means the empty set. So things that could have been a combination but didn't actually have a country that instantiated it. So the word instances is used here in a special way to mean that the outcome did occur, or in this case, that the conjunction occurred. So there's a lot of white. There's only a few combinations. That's limited diversity. So it's a good illustration of Reagan's themes. The pale grey is where there's no survival of democracy. I'll just list the countries which at that time did have the breakdown of democracy: Greece, Italy, Portugal, Romania, and Spain. And it's a sad tale, really, isn't it? But that's what happened. There is a middle grey colour showing contradictions. So that's the other countries, including Belgium, Netherlands, UK. And the analyst does kind of look at it in a technical way for a few moments, thinking, well, if that's a contradiction, I need help. I need to work on that. Otherwise, it's going to cause a lot of difficulties in writing up the results. If you can move away from that, you can write for a short journal article outlet. If you can't, then you might need to write a longer paper and actually look into the reasons for the contradictions. So what you do next is up to you, and some people would apply other methods. The source for that Venn diagram is, as I say, Tosmana software and Ryu and Demir's chapter in Ryu and Reagan's book. So Ryu is another author writing about QCA. His base is in Belgium, and the book that he and Ragin have produced is called Configurational Comparative Methods, the Qualitative Comparative Analysis and Related Techniques. So they say that this is a school of methods and not just a single method, but they do have these factors in common. And they say, and I think we all agree, that sometimes it's useful if you have a contradictory configuration to go back and try and find a fresh factor that can resolve that contradiction. In other words, looking for an explanation to why one group is different from another group. So why did Germany have that breakdown when the UK didn't? Or looking at Belgium and the Netherlands and the differences in their experience. So these are strengths of the method, but I have to mention that the treatment of time is a weakness in the method. As it's so far typically applied, it's a static method with a summary of the conditions of a case over all time, a person and their ethnicity. But we know that in reality, ethnicity can change. So I could marry someone or have a child from someone and end up in a more mixed ethnic position, or I could change my religion or my language. So ethnicity really isn't fixed, shouldn't be taken as fixed, and QCA has a tendency to take conditions and characteristics as fixed. Well, I've got a few illustrations of other forms of data management just to show you, and then I'll be concluding. The first illustration is the 0 and 1 truth table. This is a truth table from a fuzzy set analysis. It's a sociological study based in India. Some columns are fuzzy and some are crisp. But when we make the truth table, we simplify the fuzzy sets to make them look like zeros and ones. And here's the number of cases. 1, 4, 1, 2, 3, 1. There's different numbers of cases in different rows. And that data table reflects something that was worked on in a spreadsheet for 39 interviews. So n equals 39 here. The conclusions from that study were very ambiguous. So when I come to the end of the software routine, I have some measures and calculations that I can do. And the results for that particular study in India were very ambiguous. It was a very agency-oriented study rather than structurally oriented. If we do studies of social structures, we tend to get very clear results. For studies, things that are more malleable and flexible and fluid, we may not get a clear result. But that in itself is interesting. So we measure the consistency and coverage of the measures offered by the software for sufficient causality. Now, these are complex terms which have mathematical definitions in the Boolean algebra. So I'll just say briefly what they refer to. And you can kind of get it if you listen to these definitions in words. And then the mathematical definition conforms to that. And it's actually really easy to measure consistency and coverage in a spreadsheet. It turns out you only need minimum and maximum functions. It's very simple. So consistency, you can think of it as the percentage of the instances within a configuration. So what percentage of the configuration A, B, Y, and A not B, Y, actually had A, B associated with Y as opposed to not Y? So it would be 1 if it was a configuration that was all instances of Y. It's only if it's a contradictory configuration that the consistency comes below 1. So it might be 40% or 80%. And it has to be quite high for us to conclude that there's sufficient causality. Coverage, on the other hand, is a more overarching term. It's the percentage of all the available cases that are covered by a configuration. So that little configuration there has 100% consistency, 1.00, but it only covers 3% of the cases. So it's not very interesting. So we have there consistency and coverage for sufficient causality. And there's a separate definition of those two for necessary causality. So I want to come to conclusions so that we have time for questions. And I'm happy to answer questions about any of this. To summarize, I think I've shown that QCA is systematic, but it's still fundamentally qualitative. I've shown that it's sophisticated, and it has some mathematical component, but it's still holistic. And the holistic element is where we're not being individualistic, and we're not being atomistic, but we're looking at a configuration as a whole, as something which has a quality to it. It might have emergent properties, as I would put it in realist terms. QCA affects the research design by supporting an iterative method. There aren't simple stages of research, so you can return to the data gathering stage after you've done some analysis. And QCA can support causal interpretations. Now, I have to say, because some of you are going to be wondering, can it do non-causal analysis? Yes. You don't have to take the causal route in interpreting the results. For example, in hermeneutics and linguistics, you can sort of say there's an outcome as a pretense and say, let's look at the patterns associated with that outcome. Get all the results, including consistency, but you don't have to interpret them in terms of the causes of that outcome, but rather the things that appear to associate with it, which would be patterns, habitus, tendencies, maybe discourses, or taking turns in conversation analysis. So it has been used in hermeneutics, but less so. So I'll welcome questions on all this material.